Welcome to P-Clark Calc, Practical Calculus for the Busy Math Student. In this video we're going to take a look at a couple of examples that use the quotient rule for derivatives. Here we're looking at the rational function g of x equals 4x minus 5 divided by x squared minus 1. And in order to find its derivative, we're going to have to use the quotient rule. And the quotient rule is the rule for taking the derivative of a fraction. And using the u and the v substitute variables, which most students prefer, we can state the quotient rule this way, that the derivative of u over v with respect to x is equal to vu prime, which is the denominator times the derivative of the numerator, minus u times v prime, which is the numerator times derivative of the denominator, all divided by v squared, or the denominator squared. So when we decide that we have to use the quotient rule, we take a second and say, well, what do we mean by u and what do we mean by v, right? And it's pretty cut and dry in the quotient rule because u always means the numerator. So u is 4x minus 5, and v is the denominator. So v is x squared minus 1. So depending how comfortable you are with it, you may be able to just state the quotient rule at this point. But sometimes it helps in trickier situations, especially to do a little bit of scratch work and do the little calculus on the side and say, well, what are these derivatives u prime and v prime? And those are done with the basic rules, so power rule and that sort of thing. So u prime is 4 in this case, and v prime is 2x. So when we go to run our quotient rule, kind of the rough draft of the quotient rule, it looks like this, where we just work through our formula. Now the formula itself is proven by the limit definition of the derivative, and it's pretty tricky when you look at the proof, but luckily you don't have to memorize the proof, you just need to know the rule. And so it states that we take v, right, the denominator, so that's x squared minus 1, times the derivative of u prime, which is 4, and then we're subtracting in the quotient rule. So vu prime minus uv prime. So u is 4x minus 5 times v prime, which is 2x. And that's all divided by v squared. So that's x squared minus 1 quantity squared. So when you do the quotient rule, that's what the rough draft will always look like. And if we label our parts here, you know, we have our v u prime for starters, and then we subtract from that u v prime divided by v squared. Usually if you're going to use the quotient rule derivative for anything, though, we clean it up a little bit. And the typical rule of thumb when you're cleaning up a quotient rule is to distribute on the numerator and tidy that up as much as you can, and don't expand the denominator. Right? Expanding denominators is not very helpful, and it actually kind of can cause problems. So we're going to leave that factored in the denominator. But let's see what happens up on top here. So we have distribute u prime through v, which gives us 4x squared minus 4. The biggest mistake calc students make, if it's not on the actual derivative, it's on the algebra here, because it's the old problem of distributing a negative sign. So just be careful. We're subtracting the quantity when I distribute 2x through u there. We have 8x squared minus 10x, all divided by v squared. And for this example, will be very obvious. Let's just write one more step here. So this is the big algebra problem that is very common with calc students there. So just watch out for that. So minus x squared plus 10x all divided by x squared minus 1 quantity squared. And then we can combine our like terms in the numerator. So to give us negative 4x squared plus 10x minus 4. We put that in descending order. over x squared minus 1 quantity squared. So this is a case where you must use the quotient rule. Typically when you see the rational function and you have multiple terms in the denominator, there's really no good algebra rewrite approach to getting the job done here. Let's just make sure we understand how the quotient rule works and look at an example where you maybe do have two options. So here we have the rational function 4x squared minus 3x divided by 8 times the square root of x, and because it is a fraction, a quotient rule will work. So let's just go ahead and do it again by quotient rule. Again, u is the numerator, v is your denominator, 8x to the 1/2, right, if we're going to do our derivative. And then if we just do the smaller derivatives inside of our quotient rule, so u prime by power rule would be 8x minus 3, and then v prime, we're taking the derivative of 8x to the 1/2 here, so that's going to be 4x to the negative 1/2. So if we take that result and we put it into our quotient rule, then this is our result. So 8x to the 1/2, and we may as well stay in rational exponent form here, times u prime, which is 8x minus 3, minus u times v prime, which is 4x to the negative 1/2. All divided by 8x to the 1/2 quantity squared. I'm going to violate the rule I just said in the last example, but because I have a monomial here, I'm going to square out that denominator. It'll help me tidy things up. So we're going to go ahead now and distribute through on our numerator in a couple of places, right? So I'm going to take my 8x to the 1/2 and distribute it through my u prime factor, and so that gives us 64x to the 3/2 minus 24x to the 1/2 minus the quantity, and again, careful on this one, and we'll distribute here. And so when we do that, the result is 16x to the 3/2 minus 12x to the 1/2. And again, because it's a monomial in the denominator here, I'm going to square that out, square each factor, so that gives us 64x. So if we tidy it up a little bit more, right, if we're careful, maybe we can do this in one step this time if we combine our like terms. But just remember, we're distributing that negative sign through the uv prime part of my quotient. And again, that's a huge sticky point for calc students. So, but if we combine the like terms, we have 64x to the 3/2 minus 16x to the 3/2. So that's 48x to the 3/2. And then we have a negative 24x to the 1/2 plus 12x to the 1/2. So minus 12x to the 1/2, all divided by 64x. And what we can do at this point is divide through. Since we have the monomial in the denominator, if I divide through each of the two terms here, we have 48x to the 3/2 divided by 64x to the first minus 12x to the 1/2 over 64x to the first. So we can go ahead and we can use our quotient rule for exponents. When we divide through monomials, we can reduce the fraction part of that. So in the first term, we have common factor of 16 there, so it's 3/4 x to the 1/2, we'll call that. And then for our second term, we have a common factor there of 4, so it's going to be minus 3/16 x to the negative 1/2. And it's okay to have negative exponents in your answer. Depends what we're doing with our derivative, but we're going to go with that. So that's finding the derivative of the rational function using the quotient rule, and it works fine, but it's probably too much work. When you see an algebraic rational function and you see a monomial, single term, on the denominator, you should divide through. You should take an algebra first approach here on this particular case and save yourself a lot of trouble, because the quotient rule is one of the lengthier rules in derivative calculus. So if I do the rewrite on the function and divide through by 8x to the 1/2, I have 1/2 x to the 3/2 power minus 3/8 x to the 1/2. So when you have the single term in the denominator, dividing through puts me in a position where I'm back to using the simple rules, and I don't need to use the more complicated quotient rule here. And so if I run the power rule on that, we end up with 3/4 x to the 1/2 minus 3/16 x to the negative 1/2. It's hard to argue that wasn't the easier way to go in that case. So we've seen two examples where we use the quotient rule here. The first one, we absolutely had to use the quotient rule because of the two terms in the denominator. And in this case, where the quotient rule would work because it is a rational function. But when you have that single term in the denominator, you should divide through, go with the algebra first approach. If you'd like to learn more about the quotient rule or derivatives in general, you can find those in my textbooks, available on Amazon for a nice price. And don't forget to subscribe to the P. Clark Calc channel if you liked it. Until next time, I'm P. Clark.